Similar triangles. The definition of a similar triangle is two triangles with identical angles. So, for example, this, I've actually drawn one triangle on top of the other triangle, but they've all got the same sized angles. So if I call this the smaller triangle, triangle A, and the bigger triangle, triangle B, if I split them up for a moment, that's triangle A, this is triangle B. Notice that these two angles here are common for both the small and the big triangle. If I call that, what shall I call it? Alpha. There we go. Those angles are all the same. The same can be said about this angle and this angle. They are identical angles, and the reason that is because they are actually corresponding angles. Notice I've done two parallel lines here, but because that angle and that angle are identical, let's call them beta, that must mean the third angle also must be identical. Notice I could write the same equation for both those angles, and that would be 180, because remember angles in a triangle add to 180, minus alpha minus beta. That would apply to that angle, and it would also apply to the other angle. So you say, what's your point? Okay, I just want to define what similar triangle means. Similar triangle means that you've got two triangles, but all three angles inside are identical. The triangles can be different sizes, right? But the angles inside the triangles have to be identical. Then you've got a pair of similar triangles. There's another word that you may or may not have heard. I'm going to spell it correctly. C-O-N. What does that mean? Yeah, it says congruent. What does it mean? No, anyone know? Congruent triangles are triangles that are the same size and have the same angles. So identical triangles, except they could have been rotated or reflected. So here's an example of congruent triangles. Oops. Okay, so I've rotated them, but this angle and this angle are the same. This angle and this angle are the same, and this angle and this angle are the same. And all the sides, that side is equal to that side. Sorry, that's equal to that side. This side is equal to this side, and this side is equal to this side. So identical triangles, but either could have been reflected or rotated, but the size of the triangles are identical. Put that away for the, to the side for the time being, where I really want to focus on similar triangles. Had I told you the lengths, let's go back to this problem. Had I told you the lengths of two of the sides, say the triangle B was 10 by say 8, and triangle A was, say, 6 by question mark, we can figure out the question mark by looking at how much triangle A has scaled up, because they're identical triangles but just been increased by a scale factor. Now this is the rule, and you'll hopefully remember this. Okay, can you remember this? Big divided by small is equal to big divided by small. What I mean by that is, watching, 8 divided by 10. You see where I got those numbers from? Thank you. I even made a mistake. Big divided by small. 8 divided by 6, so it's not 10. Must equal, again, big divided by small. I'm making a mistake. Big divided by small, 10 divided by 6 is equal to question mark divided by 8. See if you can see what I've done there. Big divided by small equals big divided by small. You happy? Ah, 8's big. Is that better? Yeah. Big divided by small equals big divided by small. Jordan, is that right? Yeah. Okay, so now I've got an equation. Now I've got an equation with one unknown in it. I can solve this equation. Watching? Now, you'll need to remember this set of algebra, right? .8. Thank you. 4.8. So this smaller side is 4.8. Now, had I been doing this without projecting it to you, I would have worked it out on the calculator and I would have gone, hold on, I've got a bigger number for the question mark than 8, and I would have gone, hold on a second, I've made a mistake. So you'll always know if you've made a mistake quite quickly by you should end up with a smaller number than the biggest triangle. Okay, let's take another example. Remember that formula, big divided by small equals big divided by small. The other way you could write it actually is small divided by big equals small divided by big. It doesn't actually matter, as long as you have a big and a small, or a small and a big on both sides. Okay, look at this problem here. And I'm going to tell you that this is .35, and I'm going to tell you that this is 35. Now, by geometry, these are similar triangles. The reason they are similar triangles, Sean, you can help me out. How, Sean, does this angle relate to this angle? Because they're vertically opposite angles. So, again, I use the symbol alpha. Those two angles are the same. Now, given I've told you that the other angle in the triangle is 35, then this must be 180 minus 35 minus alpha. And this same is true here, right? 180 minus 35 minus alpha. So those two angles are the same. Hence, I have similar triangles. Okay, give the problem some numbers. 12 and 6. Use easy numbers. And we'll name this one 8. And we'll ask the question of that side. Remember, big divided by small equals big divided by small. Let's see if I can get it right this time. Big divided by small, 12 divided by 6 must equal big divided by small, 8 divided by question mark. Now, that's a true statement, but I could also inverse this, or invert it. Small divided by big, say 6 divided by 12, should equal small divided by big. Question mark divided by 8. Solving this problem, because it's slightly easier than solving this one, question mark is going to equal 6 over 12 times 8. See what I did? I multiplied both sides of the equation by 8. 6 over 12 is 0.5. 0.5 times 8 is 4. Coming back to my problem, question mark equals 4. Those triangles had a scale factor of of 2, right? So one triangle is twice the size of the other triangle. So hence I should be able to find any unknown side as long as I know the scale factor between two sides. Let's say I asked you for this side, y, right? Can anyone tell me the length of y? Look where it is. It's on the big triangle. Scale factor's 2. Any solutions? Before I confuse some of you, there are no solutions because I don't know the side of the smaller. I need to know this side to be able to work out this side. There is a method, but I haven't taught you it yet. But in terms of the scale factor, you need the small triangle side to find the big triangle side by a scale factor of 2. But you don't know the small, you don't know the big, so you've got nothing to multiply to find the new side y. Just as a side, to find the new side y, and I'm going to teach you this next week, we would be using trigonometry. We would be using this angle in here and would be trying to find the hypotenuse.